And before starting the seminar, just short self-introduction because some students doesn't know the name. So start from me to go around this. Okay. 最初に日本語で市川です。調教します。よろしくお願いします。Maybe
はい、どうも。はい。
ことを知ってるんで、自己紹介名前だけ自己紹介して。
Yeah, okay. Just
self-introduction, only your name and your the course.
Okay, my name is Manahan. I came from Indonesia. Now I am a start to Dr. Program. Nice to meet you.
東工大西洋4年の山岸康介です。よろしくお願いします。
英語で。
I'm senior in Tokyo Institute of Technology, majoring in system controlling. Nice to meet you.
Kenshiro Komori, master class. Nice to meet you.
My name is Tomokazu Maeda. I went to Yokohama National University. Nice to meet you.
I'm Yuki Igarashi, master course. Nice to meet you.
I'm Kazuko Yagisawa. I'm in first grade of master. Nice to meet you.
I'm Hiroshi Deguchi, the boss of this. And maybe you can find a wide exit on the internet.
Nice to meet you. My name is Daisuke Torigai. 僕は I'm second degree on master course. Nice to meet you.
I'm Chonghan from China. I'm first year doctor student. So nice to meet you.
My name is Shuza, but in Japan you can call me Seth. I'm still a research student. Nice to meet you.
My name is Oscar. I'm a third year doctoral student. Nice to meet you.
My name is Nguyen. I come from Vietnam. I'm now the first year doctoral course. Nice to meet you.
I'm Hiroshi Oda and master course first grade. This seminar top class. Nice to meet you.
And we have two more students and one more staff, but one is in China. He went back to China because of maybe you know. And one student maybe he'll be here in maybe next 1 hour. I don't know, but we will start the seminar. Okay, today I'm chair today, but usually the chair will be the one of you student do this post. Okay, but today I will do that. And today we have 6 presenters. Okay, and the important thing is that both Professor Deguchi and I have the meeting from 1 p.m. Okay, so we cannot extend the seminar.
It's a SWAS developing seminar. Usually every week we organize a SWAS developing seminar. As you know, SWAS is our developing social simulation language. So if you're interested in SWAS itself, you can attend the seminar. But it is quite hard seminar for professional standard, not an amateur standard. Okay.
And as I announced, each presenter has 15 minutes. Okay. But don't hesitate to stop for question and I will check the time. So if there are many questions, maybe there are a lot of lost time.
Good.
So presentation is just 15 minutes, but there are extra.
Okay. Question! Objection! Okay.
So please, so I request the presenters to stop for asking everybody their questions for each slide or maybe one section. So first presenter, Yoshioka, please start your presentation.
Let me start.
I'm sorry. And I will give you in 10 minutes, 15 minutes.
Let me start my presentation. First, I introduce myself. My name is Yoshioka, and it's my characters. I'm from Tokushima. I graduated from Osaka Prefecture University this March. And I also studied agent-based simulation there. Next, I introduce my hometown, Tokushima. Tokyo is here. My previous university is here, Osaka. Tokushima is in this area. It is a main station in Tokushima. And it is our odori, a traditional dance in Tokushima. This festival is held in summer.
Can you play our dance?
Of course. All people of Tokushima practice it in elementary school. Next, research of selecting Deguchi Lab. I selected this lab for 3 reasons. First, this lab is at the forefront of system science. And second, there I can find one from various research team.
あ、まあ、地震が Lost time 今の地震情報あるでしょ 1 2 3 4
Finally, the members are from various regions and so international. And next, I present my previous research. My previous research theme is agent-based survival strategy on the regulation sugar scale introduction on learning. Sugar scale model is a basic model of agent-based simulation. And sugar scale is an artificial society where agent lives by gathering sugar as food resources. In conventional sugar-scale model, they didn't think sugar degradation and money, trade. In my research, I invented then the sugar scale. By this invention, by this innovation, I can find why money is emerged. In this research, I thought these four societies, and actually computed these three scenarios, from 1 to 3. This is a result of computation. This graph describes a total asset of social in society, in each society. Set a time in horizontal line and asset in vertical line. Sorry, written by Japanese, it's a mistake. Front of first society and second society, third society. As you see, by exchanging sugar to money, and able to make economical losses smallest. By this result, by this result, money emerged for preventing by this result, money emerged for preventing negative economical effects. Finally, I presented research topics. Today, I suggested 2 new topics. First one is adult T-cell leukemia. This is an infectious disease eccentrically located in Japan. In this demo, I can simulate a quantity of virus in one patient's body and translate the number of patients in one society.
Question. In the case of HTLV1, maybe so many cases so vertical infection from mother to her child. Is that right? Main reason of infection is from mother to her child. Is that true? HTLV1 in the case. Yeah. Infection process. 感染ってどうやって起こるの？ね、親子間の垂直感染ベースじゃなかったっけ？
Yes.
Yes. Vertical from so mother's body to
Yes.
her child. Okay, thank you. Please continue.
Another one is utilization of local communities. In this theme, I can simulate upgrading of the transportation infrastructure and attraction of big business to local area. So, for example, where should Yokohama based baseball team transfer for creating positive economical effects?
But why not the case of Tokushima? Yokohama is already
Transfer to Tokushima.
to Tokushima.
To Tokushima.
Oh.
Niigata. Some various local areas.
But there's no incentive for bastards. Okay, please continue.
This is my sample. How about two topics? Professor Deguchi.
Yeah, if you're interested in revitalization of the local community, maybe in this disaster it is a very, very important case study, because in the area of Tohoku district, we have to redesign total communities. So if you're interested in that topics, maybe please try to the topics. Anyway, seminar is not the communication between I and the presenter. You are all attendant.
Yes.
Don't hesitate.
What are the Yokohama based on? Yokohama based on what's that?
Japanese baseball team.
And what's the problem with them?
Yeah, good question.
This team
It's very bad.
is bad condition.
The last year's record is worst, and also the money.
Okay, by your research about Superscape research, I can find it net logo. In net logo library, there's 3 versions of Superscape simulation. You can try find net logo and go set up and go use. You can see that well, this is a pattern of the society, and the interaction between the agents can construct the society and wealth distribution and other. You can find it on the web about Superscape game of life. Is a very interesting. So you can find.
Question.
According to the Gwen-san's comment, maybe a Japanese student read 人口社会複雑系とマルチエージェントシミュレーション。Maybe you can find in that. I don't know where it is, but it talks about the Sugarscape. And English one is growing artificial societies. Maybe it is not in our lab. Maybe we should buy that one. But it's
growing artificial society, English version. Maybe it's allowed there. I don't know where it is. But if next time I can find it, then I'll move to on the PDF version. Maybe I can.
Maybe everyone should read this one, because this one is maybe the first model for us to refer.
But it's too classical.
Yeah, classical, but it's it's good to understand the
Yeah,
history
yeah,
of
of course,
agent
of course.
based.
Is that was written by Epstein?
Yeah,
Yeah, yeah. And Axel.
yeah, still on it.
Just
Translated by Hattori-san.
yeah, yeah. The also Epstein. Last 2 weeks ago, I attended this conference just held at the University of Pittsburgh. I met Dr. Epstein. He's a very, very old person, but he's now active. And he's in John Hopkins University. Maybe we can collaborate with him about the model of smallpox. Okay, please continue.
That's all for my presentation.
Okay.
Thank you for your attention.
Any questions, comments? Okay, you can select the next presenter.
Mr.
Today, I'd like to talk to you about decision on conditions for selecting clients from young experimented. My name is Thomas Maya, and I went to Yokohama National University and studied physics there. This is our conservation devices in Chile batch. Outside, many small devices measure number of electrons. This inside devices in central house measure number of gas. They are called yak. There are many games where cosmic ray enters the Earth. Neutral ion immediately decays and becomes gamma ray. Gamma ray becomes a pair of electrons. In addition, the electron radiates a gamma ray. This phenomenon is called air shower. This is one of many small devices. When an electron goes through the scintillator, the light of the scintillator is happens. The device is PMP is changes the data for distance from the center and density of gain. The data are used for fitting. And this area is calculated by integrating signified number of electrons. Next page is selective condition. Gains of less than 40 means tera electron volt are removed by adding conditions. Number of electrons is more than 40,000. Gains per are removed by adding conditions. The total of number of bursts is more than 3,000. When I added these conditions, I had faced a problem. About 83% of the when is a peripheral event. I need to add a next condition for solving this problem. Gain events energy is not intensive are removed by adding conditions. The total of number of bursts of 4 inside devices is more than 35% of total of all. The number of gains from 5 to 10 meters decreases because of statistical error. Distance from air shower point to the center of the devices is less than 5 meters. There are conclusive selective conditions in all. This page is the process core events are selected. That's all. Thank you for listening.
Any questions?
I hope your contribution, every presenter, if I make a comment, I'm quite exhausted. It's your thing, okay?
I didn't understand. How do you want to use agent-based simulation?
One more.
エージェントベースシミュレーションはどうやって使いますか？Maybe he wants to know any idea or plans for the future research.
What's the relation between your undergraduate research and master's research, especially in the viewpoint of agent-based modeling? エージェントベースモデリングの視点から見たときに、学部のやったことと、それからこれからやりたいことと、どういうふうに結びつけるのかという、そういう 雑白に言えば。No relation, that's one. That's
全く関係ない昔の
question. What is purpose of your research?
undergraduate research.
Yeah.
マイリサーチ
or total research in Tibet.
Where is cosmic ray? Where do the cosmic ray go from?
チベットでやってる実験の全体の目的っていうか、何を目指してチベットで実験してるのか。
To understand where do the cosmic ray go from?
宇宙船っていうのは、そのガンマ線じゃなくて、
どっかにこ
宇宙船って東方宇宙船じゃなくてコズミックレイ。昨日宇宙船って聞いてる。
どこ起源の宇宙船だかみたいな。太陽起源だけじゃなくてみたいな。はい。
超新星。
はい。
What is the meaning of YAC?
The device in this house.
This house's name is YAC.
Yeah.
何をやってるんですか。Did you go to the Tibet?
No.
What kind of simulation tool? Simulation tool. I found some material about, we have Seneca, a kind of air shower simulation code. Seneca to
はい、
My name is Yuki Hirashi. Now I am going to self-introduction. I graduated Tokyo University of Science. I studied architecture. My previous research is about earthquakes. I live in Kiyoshi, Yokohama with my parents and my dog. He is Chihuahua, 2 years old. I like sports, especially basketball, cycling, and so on. My previous research is about analysis long period ground motion. Tokai, Nankai, and Tonankai earthquake is said that said to occur in the near future.
Long period,
長周期地震。Short period ground motion. Long period ground motion.
Question.
はい。
Is there was earthquake in Fukushima, near Tohoku?
Yeah.
Now?
Yeah.
And is it long period or short period?
Perhaps long period of ground motion.
Difference of short one and long.
Small building.
Okay. Long period and short period is not the characteristics of earthquake itself. It is a way of shaking depending on building or that kind of structures. So proper, I don't know exact name, but depending on the structure of building. So once shocked, then sometime and long period shaking breaks the big building as a result. That's very, very dangerous. But in this stage, short period shaking process is analyzed so well. But long period one is not so maybe analyzed. Is it right? わかんない。長周期のやつってあまり研究進んでないんでしょ。
そうですね。
だから長周期で今回 in this earthquake, well, maybe around Chiba district, big chemical plant have broken. That is called the result of long period, fluctuation. Maybe.
ゆっくり地震っていうあれニュースとかでよく聞いたんだけど、それのことなのかな。
いや、地震じゃなくて長周期振動。
すごくあまりにも周期が長すぎて地震系では検出できないんだけども、おそらくそれがエネルギー結構解放してるんではないかという
それはかなり特殊じゃない
説が
それどっち？本当の長周期の地球振動の話？長周期振動の話じゃないの？
いや、そうです。長周期地震動の話です。
地震？
地震動。
じゃあ長周期の建物の話なの？それとも？
建物ではなくて、
地震の長周期。
地震の長周期です。
じゃあ、my explanation is long, but well, if it is so now, 東なんだっけ、東北、earthquake is not that type one. This is a typical type of earthquake. Typical type. So in usual earthquake, so this type and that type.
ゆっくり地震で出てきます。
So that's quite different. Which side? Anyway. Okay, please continue.
In these earthquakes, damage of long period ground motion is estimated. So there are sedimental layers around the contour plane. Sedimental layers is layers of deposition around the trough. Purpose. Sedimentary layers are said to have effect on long period ground motion, so it is important to analyze this long period ground motion is needed. Purpose. Analysis properties of long period ground motion using earthquake that occurred in Surugabe earthquake. And simulates for the Tokai and Tonankai earthquake. And this is analysis range. Nankai earthquake focal area and Tokai earthquake focal area and Surugabe earthquake center. Observation points Yokohama, Chiba, Shinjuku, and Noda campus of Tokyo University of Science. And underground model, this is sedimentary layers. There. Left side which doesn't have sedimentary layers, right side which doesn't have sedimentary layers. I compared these two types. This is the result. Original model. Sagami trough which doesn't have sedimentary layers, and Nankai trough which doesn't have sedimentary layers. These graphs are velocity waveform graph, and this graph is velocity response spectra. Velocity response spectra is maximum velocity against period. From these graphs because small difference, sedimentary layers don't have effect on don't much effects. And next, I did research on effect of sedimentary layers using supposed Tokai and Tonakai earthquake. Observation point in Shinjuku and Node campus. Shinjuku Node campus. And this is Sagami trough, which doesn't have sedimentary layers and no sedimentary layers. And also Sagami trough, which doesn't have sedimentary layers. No, which have sedimentary layers and doesn't have sedimentary layers. This graph, non-sedimentary layers. Blue line is sedimentary, non-sedimentary layers. From these graphs, from maximum velocity in small and big. Amplitude level. Amplitude level became smaller by sedimentary layers. Non-sedimentary layers have sedimentary layers. Yes.
What is the meaning of sedimentary layers?
Sedimentary layers is deposition on plate deposition, not on plate.
Second,
Yes.
how you produce this? You do some simulation to produce this result, or is on data? Simulation. How long
you determine the long of the period of the period of attachment, how long you determine in this simulation?
These graphs, yeah. Animation is 2 days or 3 days.
2 days? This is you use some software or some software or some programming?
Yes. Using the Fortran. It is considered that sedimentary layers made energy of earthquake smaller. Conclusion: there isn't so much effect of the sedimentary layers on Sagami Tower in Suruga Bay earthquake, and on Tonankai earthquakes, sedimentary layers influence sedimentary layers make amplitude level smaller in Kanto plain. Why I chose this route? I tried not to see only construction industry, so I look around consult industry, financial industry, and so on. I was most important is in consulting company. Because I can see things in many ways, but I had no knowledge of economics, marketing, and sociology. I wanted to study more. At that time, I heard about this lab from my senior. After that, I visited this lab, and so I can do what I want here. So I chose this one. What I want to study, I want to study industrial structure, but I haven't decided details. I want to compare Japan with foreign countries. I heard that there is research using ADNet.
No. ADNet. Okay. Please Google. You can find more information about that. Okay.
Thank you.
Anyway, so you don't have much background about the economics. So in those cases, maybe I recommend you to start from management side or so companies organizational analysis. Actually, well, in standard economics, they have so strict formal framework. So it is very hard to learn it in short time. But well, of course, for compare the industrial structure itself, except neoclassical background, of course we can study that one. For that kind of study, maybe accounting point of view or organizational point of view might be better. So I recommend you to start this one. ADNet is a Japanese collection of balance sheet of all so many Japanese firms. And in United States, I forgot the exact name, but same type of collection of balance sheet. So maybe you can compare that one. So you can make a theory, comparison theory from the point of accounting structure here. So that might be the new frontier. Anyway.
Thank you very much.
Hello, nice to meet you. First of all, I'd like to introduce myself. I'm Kazuho Yakisawa. I went to Yokohama National University and my major was physics. My home city is Utsunomiya. Utsunomiya is famous for gyoza. And gyoza is in Chinese, chaozu. Utsunomiya is near from Nikko. So, very good city.
Can you prepare gyoza?
Sorry?
Can you prepare gyoza?
Yeah, yes.
Okay.
But I make miso.
Actually,
Not so
he wants
often.
to eat the gyoza. So he asked him to make the gyoza.
So we can have a card. Okay.
He also wants to eat okonomiyaki. I want to eat the Korean food.
Okay, I will learn how to do it.
Next, I speak about my thesis. The title is Applying TDC to LXE Experiment. This is abstract. First, I speak about backgrounds. There is a large project in Kamioka. It is called XMAX project. The purpose of XMAX project is to search dark matter unknown particles and so on. In this project, LXE is used as a scintillator. LXE is liquid xenon. Scintillator is that when some radiation come to scintillator, then and then scintillator makes some lights. So we need value of emission spectrum of liquid xenon but there is no good value. So my previous labo Nakamura, was Nakamura lab, started to measure that. It is known that there are two different values of emission spectrum, fast one and slow one. So we want to measure each emission spectrum separated, and we consider that it is possible with TDC. So I searched a character of TDC. TDC is time to digital converter, and it is a module that can measure a time between start pulse and stop pulse, like that. TDC can measure here this time between here, like stopwatch. And this is picture of TDC. There is one start input, 8 stop input. It is investigated for medical experiments, so it can measure their very short time. And this module has (133) picosecond time resolution. This is example data taken by TDC. Here is time scale and this is count. This is first ideal example. But we find that sometimes there are some not ideal like this data. When we change cycle start pulse. So I changed time value between two start pulses here. I changed here time. And TDC measures here. And this is my system of experiments. Function generator is functional generator is a kind of electronic test equipment used to generate electrical waveforms. And it generates two pulses, and one of the pulse had delay. And this module makes suitable for the pulse and TDC measure here and TDC count. This is result. Here is time scale. This is how much the scattering. How much is the scattering? RMS is root mean square. So I realize that when the cycle is from 200 to 1000, value of RMS is low here. Conclusion. It becomes clear that frequency of input pulse is important when we use TDC. And when we measure emission spectrum of LFC with TDC, we should control the frequency of input pulse. This conclusion. Thank you for listening. And I speak about why I choose this lab. That is very simple. I went to the explanation about course here, and I heard some explanation, and I interested in that. It seems to me interesting. That's why. And now I try to search or think about how to generate one, or how to make trend or boom. Thank you. That's all.
What's your research plan here?
Sorry.
What's your research plan here?
Here, I want to search how to make or generate movement or boom, trend, and so on.
Okay.
Usually, most of us students change their research topics when they enter the second grade.
But just several days ago, Catherine Carey, she's a famous professor in Carnegie Mellon University, has proposed me about the research program of the structure of social network in the case of Japanese earthquake. that actually include wide topics like network activity of the internet for supporting disaster rescue process. So that might be I feel very similar to your research intention.
Yeah.
So if you're interested,
how to expand the information or this, I think
actually
also
not only information but a combination of information and actual activity. That is a very interesting and very new trend, a new type of non-profit activity. Nowadays, Facebook or Twitter become a strong tool for organizing so many type of human activity. And in the case of disaster, so that kind of activity becomes so active and so quick rather than government activity. So that might be very interesting topics and important topics. Okay, anyway. Are there any questions or comments?
I once worked at hardware maker, so I think so because 100 picosecond scale is very delicate. So what you use special kind of signal cable.
TIM cable.
TIM cable. Oh, I don't know what.
I don't know also exactly, but it is there are some kinds of some kind of different long cables. And for example, this long is 5 nanosecond. This is 10 nanosecond, or that is their exact. I think.
I think if cable is curved, so
but
change.
I could take this example. So I think it shows that cable has no problem. I think.
多分触っただけで変わるんだよ。
でも実際触らないで、ファンクションジェネレーターの方では大だけ変えてやってたんで。
ケーブル触って変わるかって言ってみたらね。
でも変わらない。
そんな変わらない。
付け替えたりしても特に変わらない。
静電容量ですけど、えらい影響を受けそうな気がする。
TIM ケーブルだったと思うんですけど。ありがとうございました。
and I wish I will get a good performance today. Now let me introduce myself briefly. My name is Xue Jiao, but in Japan you can call me Sets. I come from China. This is my hometown, Xi'an. It's a traditional city in China. Maybe. Hi. It is said the king is living here many thousands years ago. Okay, I thought it was nice. My major is mathematics, and I have a lot of hobbies, such as music, sports, and so on. I can play a traditional Chinese instrument, but my baggage is too heavy, so I can't bring it to Japan. I hope I can buy a new one. Okay, let's start. Oh, first. Oh,
Show the previous.
How to read it?
So, you tell them all them that which one is the first name and which one is your family name.
What?
Family name and first name. Maybe.
Oh, this is my family name. Xue.
Chu is the kanji.
Kanji.
Chinese character.
Yes.
Okay. Hi. This is my family. Should I start? Go on. My bachelor's thesis is the Monte Carlo numerical simulation method for solving foreground equations. So on. This is the background of the Monte Carlo equation. In the linear stochastic system, the foreground equation is again an important equation of partially differential equations. For the system of the distribution function and density function, it describes the evolution of the statistical law system, which is the system dynamic different equations of distribution function. My research is aimed at foreground equation, which is from driving system constants of white noise. Do you know white noise? Oh, okay. At random. And using Monte Carlo simulation method to discuss the solution of foreground equation when the system has achieved a stable state. I just read it because it's too long. Okay. This is the pattern of foreground equation. And Wxt is the probability density of the system, and t is the time, and x is the real of the system. P n is a series of constant. We can choose it depend on the system. Monte Carlo method is a traditional method. It is used in many ways. We can maybe it can have 3 steps. It is complicated, I think. The first step, we can set the probability models, and the second step, setting the process, and in the last, statistical variability estimation. Okay. I just used the Langevin equation as an example. The Langevin equation is used to describe how to say Brownian motion. Do you know Brownian motion? Oh, okay. This equation is to describe the Brownian motion, and the foreground equation is from it we can calculate that. But in usually we come from the control equation to also get the foreground equation. It can be used in many systems. Please. I have listed 3 examples to use such Monte Carlo method to solve the problem. The first is Ornstein-Ornbeck cosines. Ornstein-Ornbeck is a very special equation because it has a theoretical solution. The Monte Carlo it also can be described as a Lagrange motions, and we get it from the equation. So this is my method. I use the Monte Carlo method to get this simulation, and this is a theoretical solution. Someone had calculated this equation many years ago. This is the time and the real of the motion. We can see when the time from 20 seconds it goes to stable. The right line is the Monte Carlo method. I use this method to get such graph. And the blue one is a theoretical solution. From such examples, we can see this method is available. So we use this method to another system. We call it definite equation. This is the initial equation. It is more complicated than the last equation, and this is a numerical simulation. Such equation can be described as 2-dimensional. So I show the connection between the time and real, the time and the probability density. And this is time and the speed of the motion. This is the speed and the speed with the probability density. The last one is a chaos system. This is also the initial equation, and this is a numerical system. We use a different parameter and get the different result. We can see this is stable, but when we choose the different numbers, we can go to a different chaos system. In reality, it will also this system is widely used. This is my things. Okay, now let me express why I choose to this line. As is known to all, mathematics is very abstract. I want to use my mathematical knowledge to use to the reality society. In the past, I'm able to something like to simulate, and I want to use a lot of data to forecast the system in the next time. In the future, I hope I can do some research on the simulation, especially for the sophisticated or complicated social system. Crystal, do you have another question?
Okay. Actually, well, Ornstein-Uhlenbeck process was, well, maybe equation, and that kind of equation is very, very hard to analyze. Of course, it's a very classical one. It's like a Brownian motion. That was maybe formalized by Einstein. Yeah, actually, Brownian motion was, at first, started by Einstein. It's a very famous history. So it's a long history of study. And nowadays it is applied, for example, so econophysics or, well, financial process model. But from our point of view, so that kind of statistical process is actually limited, but it's very hard to analyze. So in our laboratory, well, we, of course, if we can analyze the situation by mathematical formulation, for example, some statistical, non-linear statistical process, then of course it is recommended to analyze by mathematics. But the formulation is beyond, so mathematical formulation in this stage. In future, it might be changed. Then we use so simulation approach. But anyway, to combine mathematical one and simulation one is a very, very hard work. And also, so agent-based or rule-based approach, we have to so formalize more algebraic structure or strong non-linearity, like well, differential type of equation or diffusion process. So even if it is a discrete one, maybe the so operator is like a continuous diffusion operator. But well, in rule-based dynamics, change is not continuous. So drastically it changes. So the quantity of non-linearity is quite different. There's no standard way of so operator algebra in this domain. So there exists a strong gap. Actually, well, in my research, in the case of abstraction of metanol games, metanol by Robert Axel. Node is an active. My pronunciation is not so good. Node. Metanol. Analyzed by Robert Axel. I formulated Robert Axel. Axelrod. Robert Axel is a very famous researcher in complex social systems. Anyway, so he analyzed the normal process, social normal process or meta-normal process by simulation, by using the genesis algorithms. But I formulated this one from a mathematical point of view, bifurcation by using bifurcation set. But it's quite structures of actually this type of so non-linear equation, analysis of non-linear equation is very, very hard to but I hope you apply so both sides.
I just wonder if it is available.
Anyway, in this laboratory, maybe all people, I'd like to say, so you have to learn set theory, so more basic one. Actually, so many, this year, so many students coming from physics or mathematics, okay? And especially Random equation and that kind of equation coming from physics, like a Brownian motion, okay? So, so many students coming from physics are very, very familiar to so analytical mathematics, like a differential equation and then so on. But well, one of the different origin of mathematics, it's a, well, set theory, okay? Yeah. Yeah, like this one and so on. So, well, and then so on. This is the basics of modern mathematics. So every mathematical tool coming from set theory. And set theory is the basic notation of modern mathematics. And on set theory, so operator algebra and topology and matrix and operator algebra and analytical mathematics. So, of course, from physical point of view, you cut all these processes. But from social science or basic formulation point of view, we have to learn this type of basic mathematics. Okay, so in our laboratory, we are very, very focusing on this type of basic mathematics also. Well, all the message from all newcomers. Okay, anyway, okay. Thanks.
Another question? Thank you for your attention.
Anyway, first mission for you to pass the examination.
Morning everyone, my name is Chang Shuang. I'm from China as well. Chang is my surname and Shuang is my given name. So in this presentation, first I will introduce myself and say something briefly about my past research interest, and then introduce my research plan here. So for this education background, although I'm from China, but I got both of my bachelor degree and master degree in Hong Kong and UK respectively. And originally I was enrolled into the University of China studying mathematics. And then after 1 year I got scholarship to continue my studying in City University of Hong Kong studying computer science. And then I got my bachelor degree there. And then after that I continued my studying in applied cryptography and got my first master degree there for 2 years. And then at the end, I went to London School of Economics and Political Science, studying information systems and organizations. And it's a 1-year program taken by courses. So that's basically my education background. And I also worked for 2 years, 1 year as an IT trainee in HSBC Bank, and also 1 year as teaching assistant in City University of Hong Kong, basically conduct tutorials in many of computer science courses such as database systems, operating systems, and C++ programming. And during my first master degree, I also worked in Future University of Hakodate in Hokkaido for 3 months. And my research interest at that time was RFID technology. So that's basically my past experience. And for my research interest in my first master degree is applied cryptography, specialized in ring signature. So you may ask, what is ring signature? By definition, ring signature is a digital signature that specifies a set of ring members. And then when you give a ring signature to a third party, the third party cannot tell exactly which ring member produced this signature. So this definition is given in the classical paper, How to Leak a Secret, written by these 3 famous researchers in 2021. So from the definition, you can see there are very 2 nice properties of the ring signature. One is spontaneity, one is signer ambiguity. Spontaneity, that means the actual signer does not need the participation or collaboration of other ring members to produce the ring signature. And signer ambiguity, that means when you show the signature to a third party, nobody can tell actually which ring member signed this message, but they can tell this message is signed by some ring member within this ring. So the motivation and application of ring signature is secret leaking. So maybe, for example, within this Deguchi Lab, someone wants to leak some valuable information for money to a third party, then they can use the ring signature to sign this information and give it to a third party. Then after the third party got this signature, they can be guaranteed that this information is leaked from this lab, so it's true, but they cannot tell which member in this group actually leaked this information. So that's the motivation of ring signature. Yeah, I speak too fast. Yeah. And actually my work is about certificateless ring signature. So what is certificateless? Normally for the cryptography, we use the PKI, public key infrastructure. That means for each members, they have a public key and a private key pair. And they may use the keys to do some cryptography operations such as sign a message, encrypt a message. So for the public key, normally there will be a certificate associated issued by some authorities. But those certificates may cause the computation very inefficient. So in order to solve this problem, there is an alternative infrastructure called ID-based. ID-based, that means there is no public key. Users can use their identity, such as your email address, your username as the public key, and then they will let a key generation center, KGC, to issue the private key associated with each of the identity. But this one will cause the key escrow problem. That means the KGC, if the KGC is corrupted, that means all the secret keys of the members will be leaked. So that is a big problem. So in order to solve these 2 problems, certificateless was introduced in 2003 by Ariani and Peterson. Those are 2 famous researchers. So in certificateless cryptography, we allow a semi-trusted KGC to generate a partial secret key with respect to the entity of each user. And we also allow the users to generate their own public key and private key. And for this public key, there is no certificate associated. So in this way, it eliminates the usage of the certificate. And also the KGC is semi-trusted. That means we do not trust the KGC fully. So it solves both of the problems here. So that's why certificates is a hot research topic at that time. So in my work, my contribution is that actually we propose the first set of formal definitions of certificates structural ring signature. And we also produce the strongest adversary model compared with previous work. We try to model the real-life adversary attack and build models. And we also propose efficient constructions of the scheme and prove them secure under our strongest adversary model. So that's basically my first master degree. And actually during this 2-year studying, I feel that no matter how secure the scheme in mathematics, if the scheme is put into real life, sometimes the security depends on the people who use it, depends on the organizations where the scheme is deployed. So that's why I moved to London and study information systems. I want to learn something about the human side of technology. So my second master degree is course-based, and we have to write a dissertation at the end. So my dissertation is about how the privacy concern of Hong Kong ID card is perceived and constructed within the local context. And why smart card? Actually, nowadays smart card is so widely adopted. And it enables many fantastic features and promotes better services to the public. So maybe in your library card, in your traffic card, in your passport, there is RFID tag embedded. But the ability of smart ID card to collect the personal information with or without people's consent may cause serious privacy problems. So that's why I want to.
What's this in the Hong Kong Smart Identity Card system? What's that?
This Hong Kong Smart ID card is actually I have one. It's just a card you can use it to. In the room. Actually, it's like the passport. You can just put it on some machine and you can go in and go out Hong Kong, and your name, your home address, your phone number, maybe your medicine record, and many information are stored in the Hong Kong ID card. So basically, I'm not sure.
It's like a passport.
Yeah, it's
it like the guiding drug?
You're right.
All the personal information is saved in the card, so it's a plastic. Yeah, all the citizens they must have the card.
Since they become adults? When do they
Actually, after they are born, they have a card, and there is permanent card and residence card, but everyone will have it. It's there's a microchip embedded, so sometimes if you go to the library, you can use this as a library card, and then
very convenient.
Yeah, in one sentence, all your personal information is saved in this card. So,
how about the driver's license? I mean that.
Driving license. Actually, now you can choose whether you include your driving license in the card or not. It's people's options.
So what happens if, for instance, you lose your wallet and someone else got the card? What can you do with it?
Because the card is quite secure, so nobody can do anything harm if they got the card. Because there is a picture on the card, so and your fingerprint is saved in the card. So if they want to pass the border, they have to use your fingerprint. So it's quite safe.
What is the local context?
The local opt-in is Hong Kong. The local context is the Hong Kong society.
What is the structure of Hong Kong society? Do you mean the local context in this?
No, actually, it's just in the Hong Kong society, because everyone has the card, so it is how to say? I'm not quite sure about local.
How you can perceive and construct within the local context? What do you mean
Oh
the
yeah,
local context?
actually that's my flow of my dissertation. I use case study as the methodology, and I review all the newspapers, articles, and government reports on the privacy issues of the card, and also review some forums to see how people view of the privacy of the card.
So this is the in this nowadays, all people in Hong Kong use the ID card.
Yeah, they must have.
Or they must have.
Yeah, they must have the ID card. Otherwise, they cannot go into Hong Kong. So.
What's this?
I'm not sure for Japan there is a similar card or not. No, maybe it's similar to your passport.
Okay.
And like the foreigners, we have the foreigner ID card, something like that. Maybe help the government control it.
Underage people. Underage and
old people.
no, underage
Yes.
children.
Children, they have. All people have everyone in Hong Kong. They have to bring it with them.
Does it include criminal record?
I'm not sure about the criminal record, but maybe in some specific department, if they show the ID card, there should be a criminal record. But for other, maybe if you go to a library, then definitely the library will not know whether you have committed some criminal before or not. But for the government, they will know. So it's kind of the information is saved in different areas. So actually in this one I treat this technology as a risk to personal privacy, because for the past research works, if they want to study the privacy, they may actually rely on the technical assessment of the privacy, and sometimes they may ignore the layperson's understanding of privacy. So in this work, the epistemology is social constructed, so that means I think the privacy, the meaning of privacy is socially constructed. It's not a single mathematical definition. And for the methodology, I choose the Hong Kong ID card as the unit of analysis, and use the SARF social amplification of risk framework as the theory to examine those data. So there are many implications in the work. Actually, the risk perception of privacy is rooted in the normal life, as the meaning of privacy actually is constructed through the constant effort of making sense of it. We cannot define privacy as a single sentence. So what is privacy? No one can tell exactly. Maybe different people will have different interpretations. And also in this meaning construction process, mass media and interpersonal communications will play an important role. And also when we study the technology, especially for the privacy issues, we have to consider both of the objective characters of the technology as well as the subjective understanding of the technology. So that's basically my second master degree. Then actually my research plan here is to study the innovation diffusion process by using the agent-based computer simulation. It's just a tentative plan, rough idea, because I have no background on the agent-based simulation. So why innovation diffusion? Because innovation diffusion, like the privacy, is a dynamic process. There are many stakeholders involved. Maybe at the first beginning, the innovation was invented by some researchers, by a few adopters. But when it is put into use, then it will be diffused into a complex social system. And also the innovation has a disruptive nature. That means for the technology, there are so many uncertainties about the technology. And sometimes the new technology, the innovation may challenge the existing technology and may create new opportunities. So it's a dynamic process. And for the past research for the innovation diffusion, they use mathematical modeling. But mathematical modeling sometimes might not be adequate to deal with the complex social system, and they may be too rigid. to capture the dynamic consequences of innovation diffusion. And an alternative is verbal modeling. That means you use language to describe the whole process. But language is very subjective. It depends on the interpretations of the writer. So sometimes it might be too flexible to provide some scientific result. So that's why agent-based simulation might be a good approach to study the innovation diffusion. It can provide a bottom-up approach. It might be more practical. So that's also why I'm here, because this lab is good at the computer simulation. Right? And I hope I can do this research. That's all about my approach.
Okay. Anyway, so the concept of innovation coming from Schumpeter, very famous economist. And do you know Nelson Winter model?
Yeah.
This is a very, very classical technological diffusion model. And also, after the Nelson Winter is an evolutionary economist. And also after Nelson Winter model, so many types of technological diffusion model are developed. So partly mathematics and partly agent-based model. Maybe you can follow at first that type of model.
Yeah, actually I plan to do some literature review on both of the areas of the PhD.
Okay. Are there any questions?
Actually, my hobby is photography, so yeah, like with
I want to ask, why did you move from cryptography to research study?
Yeah, cryptography is quite abstract, and it's basically mathematical modeling. And for example, in my work, I propose the certificate ring signature. Actually, those constructions are quite efficient and secure in mathematics, but I have no idea whether it is still secure or not if it is put into use. So I may feel that maybe the human side of technology is more interesting because it's more practical. So that's why I moved to
Ring signature is a kind of group signature.
Yeah, but different from group signature. Ring signature is spontaneous. That I do not need to form a group. I can just include each member's public key in the group. Then so there is no collaboration of the whole group. So
yeah, actually I know very, very interesting and historical story. You know straw hat, like this one. Straw hat. Yeah. On this hat, so from top line, traditional Edo era, so many Protestant signature here and here and here and here and here and here and here, their names. Then, so ring. So who is a representative of these Protestant group? It is impossible to distinguish.
Yeah.
This is a typical type of traditional ring signature.
Actually, it's only one application of the ring signature is e-voting. When you make your vote to your politician, then nobody knows.
This is a very famous. Yes. Okay. Anyway, thank you.
Thank you.
Yes,